Europe sits much farther north than most people ever realize. Cities like Denver, Chicago, and New York actually line up with Italy in latitude. Calgary and Edmonton sit between Germany and Britain on the same latitude band. European cities like Paris, Berlin, and Amsterdam would actually fall inside Canada. Helsinki, Oslo, and Reykjavik would land deep in Canada's frozen north. For its latitude, Europe's climate is dramatically milder than it has any right to be. One primary reason is a massive ocean current system called the Atlantic Meridional Overturning Circulation. Known as the AMOC, its sheer scale is almost incomprehensible to the human mind. It functions as a gigantic conveyor belt moving warm and cold water throughout the Atlantic Ocean. This belt is driven by differences in seawater density, shaped by temperature and salinity. The AMOC is fueled by deep water formation in the high latitudes of the North Atlantic near Greenland. As surface water evaporates and freezes into sea ice, salt is left behind in the ocean. Cold, salty water is far denser than warm fresh water, so it sinks rapidly to the ocean floor. That dense cold water then travels south along the ocean bottom, thousands of meters beneath the surface. Prevailing winds near Antarctica pull that deep cold water back up to the surface through upwelling. The water travels northwest to the Gulf of Mexico, heats back up, and merges with the Gulf Stream. Powerful westerly winds carry those warm tropical waters northeast across the Atlantic toward Europe. This warm flow moderates the climate around Britain, Ireland, northern France, and Scandinavia. Along the way, evaporation and influx from the Mediterranean keep making the water saltier before it finally cools and sinks again. This system acts as a global conveyor belt, transporting warmth to Europe and cold to Antarctica. A single molecule of water takes hundreds to thousands of years to complete one full loop. Without the Gulf Stream warmth pulled by the AMOC, Northwest Europe would be as frigid as Labrador or Quebec. Multiple scientists are now sounding the alarm that the AMOC could be collapsing due to climate change. As a result, Europe might become the only part of the world that actually cools down in the climate change era. And by cool down, scientists mean potentially entering a modern ice age scenario. You might recognize this from the 2004 disaster film The Day After Tomorrow, where AMOC collapse causes a rapid ice age. In that film, glacial ice sheets almost immediately expand south and swallow cities like New York, London, and Berlin. That catastrophic freezing scenario is highly implausible, but it is at least partly based on a real scientific fear. As the world warms from climate change, the Greenland ice sheet is melting faster and faster every year. That melt is adding more fresh water into the North Atlantic, steadily diluting the ocean's salinity levels nearby. Sea surface temperatures are also rising at the same time, making the water around Greenland warmer overall. The result is water that is less salty, less dense, and less capable of sinking down to the ocean floor. This prevents the formation of the deep, cold, salty current that drives the AMOC from the Arctic to the Antarctic. In short, the faster the Greenland ice sheet melts, the faster the AMOC gets disrupted and weakened. The current slows, warm water pulling from the Gulf of Mexico weakens, and the North Atlantic gets more diluted with less salt input. This creates a dangerous feedback loop where the water becomes progressively less capable of sinking, accelerating the breakdown further. There is an unclear tipping point in this feedback loop where the AMOC will not recover for centuries. Even if humanity completely reverses climate change and radically slashes emissions, it may be too late. Because water takes up to 1,000 years to travel a full AMOC loop, restarting it takes just as long. If the AMOC shuts down past its tipping point, humanity will face consequences for many centuries to come. Scientists have been warning about AMOC's weakening since at least the 1960s. Since then, researchers built a complex ocean-spanning monitoring system to actually track what is happening to the AMOC in real time. A key part of this is the Rapid Array, launched in 2004 in a collaboration between the UK and the United States. The rapid array spans the North Atlantic between the Bahamas in the west and the Canary Islands in the east. It consists of 24 subsurface moorings with sensors stretching all the way down to the ocean floor, measuring currents, temperatures, and pressure. The rapid array has been continuously collecting data for more than 22 years since its launch in 2004. The data that these monitoring systems have returned on the AMOC's condition is certainly troubling. The AMOC's transport strength is measured in units called sverdrups, where 1 sverdrup equals 1 million cubic meters of water per second. The observed trend line in the rapid array data shows the AMOC's strength has been clearly declining since 2004. In concrete terms, AMOC's strength dropped from 18 to 19 sverdrups between 2004 and 2008, down to around 15 to 17 by 2020. A 2025 paper in Geophysical Research Letters confirmed the AMOC has been gradually weakening by about 1 sverdrup per decade on average. The big fear is that once the AMOC drops to 6 sverdrups or below, it will enter its full shutdown phase. The key questions are how much further it will slow, whether it will hit the tipping point, and just how severe the consequences will actually be. Frustratingly, there is a massive amount of scientific opinion on these questions pointing in radically different directions. Researchers cannot yet confirm whether human-caused climate change is actually driving the AMOC decline or whether it is part of a natural cycle. 22 years of rapid array data is simply not enough time to answer that specific question with any scientific confidence. Researchers estimate they will need at least 29 years of data before reaching a reliable conclusion on the cause, meaning we likely won't know for certain until at least the year 2033. We do know that AMOC collapse has happened before, around the end of the last ice age, roughly 12,000 years ago. Melting North American and European ice sheets dumped enormous amounts of fresh water into the North Atlantic at that time. This diluted the ocean, disrupted density, and shut the AMOC down in much the same way scientists fear today. The result was massive cooling across North America and Europe, with temperatures dropping by 3 degrees Celsius in North America. European temperatures dropped by 5 degrees Celsius, and Greenland temperatures plummeted by a staggering 10 degrees Celsius during that period. These changes happened rapidly in geological terms, over just a few decades, rather than the days shown in the movie. This period is known as the Younger Dryas and lasted roughly 1,000 years before the AMOC restarted. Whether this is going to happen again in the near future is a matter of enormous scientific debate right now. But there are already warning signs the AMOC is entering a slowing phase, beyond just the rapid array measurement data. A cool blob of ocean just off the coast of Greenland is the only part of the world's oceans actively cooling down. This is precisely where melting Greenland ice would dump fresh water and dilute local salinity as the AMOC begins slowing. This cold blob near Greenland, a true worldwide anomaly, has been cited as further evidence that the AMOC is breaking down. The IPCC's most recent 2021 report stated it was confident the AMOC will decline over the rest of the 21st century. However, the IPCC maintained medium confidence that the AMOC will not outright collapse before the year 2100. The IPCC concluded the AMOC will most likely weaken by between 24% and 39% by 2100, depending on emissions levels. However, a large body of scientific research argues that the IPCC models assume unrealistically high stability for the AMOC. One major criticism is that the IPCC models have not incorporated the massive volumes of fresh water being dumped into the North Atlantic by the melting Greenland ice sheet. This omission is because including Greenland melt data dramatically raises the computational power required to run these models. As a result, many scientists argue the IPCC has been consistently underestimating the real danger of a full AMOC collapse. A 2023 paper published in Nature by Peter and Suzanne Ditlevsen of the Niels Bohr Institute in Copenhagen found alarming results. Their analysis argued that if global emissions continue rising, an AMOC collapse could occur somewhere between 2037 and 2109. But a 2025 Nature study by UK Met Office researchers backed the IPCC's conclusion, finding a collapse before 2100 remains unlikely. Stefan Rahmsdorf, one of the world's leading AMOC experts, analyzed the handful of models extended beyond the year 2100. He found that under a high-emission scenario, the probability of collapse rises to a staggering 70%. Under that scenario, the collapse most often takes place in the early 2200s, roughly 2 centuries from now. Rahmsdorf has studied the AMOC for over 35 years and once believed the odds of collapse were only about 5%. Now, armed with greater evidence, he believes the chance of collapse is closer to 50-50, essentially a coin flip.